Hello, welcome back to my channel. Today we are going to solve Leetcode problem 139, word break. So we are giving an S string, and then we also have a word dict. So the string, for example, this one is Leetcode, and word dict is Leet and code. We're just going to check if this string can be combined by any element inside the word dict. For example, lead and code can be combined to lead code. So we're gonna return a true. Otherwise, we're gonna return a false. For example, this is a cat, it's inside. The sand is also inside, but ONG is not inside. We can also take dog, but SAN is not inside. Cat is inside, but AN is not inside, so we're gonna return a false. So for such kind of a problem, normally we can use DFS and memorization, or we can use DP directly. So for this problem, I would rather to use DP to solve it because of the time complexity of DP is much faster than DFS. So let me explain how can I solve it in DP. Now let's go to the whiteboard first and then go to the code editor, finish the coding. So for example, we have lead code and we have a word dict, we have lead and code. So for the DP array, I'm going to define a DP array. So the length of the DP array would be n plus 1. Because the lead code, the length of the lead code is s, it is n, but the DP array will be n plus 1 because I want to set a true at the first position. Why? Because I'm going to check the other state. So the DPI means up to this string I, we can combine by the word dict. For example, if DPI equal to 1, so is L can be combined by lead and code? Of course not. If this equals to 3, can lead be combined by lead code or any one of them? Yes, there is a lead, so this place is going to be a true. So let's go to the code. Can the lead code be combined? Yes, we have lead and code, it can be combined. But how are we going to do that using the DP array? We're going to use two loops. The first index will be I, and the second index will be j. So I will be the outer loop and j will be the inner loop. So for I will start from 0. If I start from 0, then I'm going to check the character one by one. So if I start from 0, so I'm going to check this L first. So what L will be start? 0 here pointed to this true, DPI equal to 0, pointed to true. But for L, I'm going to check this I to I plus 1, I to j. So j will start from I plus 1. So I plus 1, it means the first character is L. So if I to I plus 1, this L is inside the word dict or no. So it will be I to I plus 2. So LE is not inside, and then LEE is not inside, and then it goes to LEET. Is this lead inside the word dict? Yes, it is. So I'm going to set false to true, because before the first place will be true, other places will be false, and now I find there is a true, so I'm going to set it to true, and then I'm go to the next character. So the I will start from this character, because here I will always be false. So until this I becomes true, when I becomes true, this is index 4, but for the character, it goes to index 4, it is this C character C. So I'm going to start from I to I plus 1, I plus 2, because Z is I plus 1 to N plus 1. So is C inside lead and code? No. Is CO? No. Is COD? No. Is the code? Yes, it is. So I'm going to set a true at this place. So finally, I'm going to return dp minus 1. Yeah. So it's gonna be a true. If this place is still a false, so dp minus 1 is false. Yeah. So this is basically what am I going to write the code. Yeah. So I will go to the code editor to finish the coding. After that, I will optimize it, because this is a solution of n squared times m. N is the length of s, and m is the length of the word. For example, here we used two loops. and we're also gonna check if one word is inside the word dict. Yeah. Now let me write the code. You can understand the time complexity easily. So as I said, I'm going to use dp. So I will first check the length of the string, and then I'm going to define a dp array. So the first place, as I said, it will be a false. It will be a true because we will always check if this substring is inside the word dict or not. But the first place, it will always true. And then, so here will be a true, and then we need to plus false times n. So this is the dp array, and then I'm going to use for loops. So for I in range n, and for j in range I plus 1. Why? Because in this way, I'm going to check if a s string I to j, it must be at least one character. It cannot be empty. Yeah, because if we check if a word inside the word dict, empty must not inside. So here I will use I plus 1 to n plus 1. Why? Because here is the dp array. The length of the dp array is n plus 1. Yeah, the length of the string is n. So this is why here we're gonna use n plus 1. And then I'm going to check. So if this dpi is true, so from the 0 place, if it is true, I'm going to check if a word is inside. If the and let's check the string I to j. So this is from the first character L and then LE. I'm going to check one by one because I will start from 0 and J will start from 1. So 0 to 1, it is L character. 0 to 2, it is LE character. Yeah, so if this character is inside the word dict. So here, word dict, I'm going to turn it into a set because for a set, it is only one time. So the word dict should equal to set word. Yeah, if it is inside, I'm just gonna set this dpj to true. Because for the s string, the j is not included. Yeah, but the dp array is always longer than this s. Yeah, it is should 1 plus n. So the dpj at this place should set to true. And then I'm gonna return my result dp minus 1. Now let me run it to check if there are any mistakes. There is a syntax error. Yeah, let's try dp minus 1. I did something wrong. Oh, it can. I didn't write the right. So it should return dp minus 1. Yeah, as you can see, it passed. Now let me submit it before I optimize my solution to n times m squared. M is the length of the word. Yeah, as you can see, it passed. And let's check the result. Yeah, it is like 90%, but this is because the testing data is not so large. We cannot check the difference. But for this one, we also know that the length of the word is maximum 20. So we can use this to speed up, because here we check the length of the string s, we checked 300, but we don't need to do that. We can check only 20. So what are we gonna do? We're just gonna use a min, because minimum should be I plus 21, because here I plus 1 and maximum I'm going to check 20 characters for a word, maximum of the word. So here I will use I plus 21 with n plus 1. So I'm going to take the minimum. Because if n is very big from the beginning, so I will always use I plus 21 because I will take 20 characters. But when this index thing goes to the end, so I'm going to use this n plus 1 because n plus 1 may be the minimum. Yeah, so that always depends on the I. Yeah, the position of the I. But in this way, the type complexity will be reduced to n times m squared. N is the length of the string, it is 300, and m is the length of the word, it is 20. So 20 squared, it is 400. 400 times 300, yeah, so it is 120,000. It's not a big number, so it can pass to the Leetcode testing cases. Now let me submit it to check if it really works. Yeah, as you can see, it works and it's pretty fast, nearly 100%. So this trick is very important for Leetcode hard problems. Some hard problems is converted by medium problem, but you need to use one or two tricks. So this is a very good trick. Yeah, if you check the descriptions below carefully, if you find this condition, so you're gonna speed up a little bit. Thank you for watching. I think you can get some hint from this question, and if it is helpful, please like and subscribe. I will upload more Leetcode problem like this. See you next time.